Water. We swim in it, fish in it, sail on it. We drink it to survive. It covers over 75% of the Earth's mass. It is the most precious resource we have, and yet, despite its beauty, despite its many valuable uses, water, whether in a river, lake, or ocean, can be a deadly force of nature. Regardless of ship size, from offshore oil vessels to tugs and commercial fishing boats, the sea has claimed many lives. No vessel can be considered too safe when going up against the wrath of nature. In addition, unforeseen accidents such as fires, equipment malfunctions, and capsizing can trigger an emergency evacuation of personnel that will put a crew in even more harm's way. That's why it is vital to understand the use of marine distress signals, from radio communication and visual markers such as flares, smokes, or rockets, to electronic locators such as EPIRBs and SARTs. These life-saving devices help aid in the successful search and rescue of a ship's crew. In this program, MOXIE Media will present the detailed use of the most effective emergency distress signals utilized in the working maritime industries, from the very simple to the advanced. The one critical element they have in common is that just one of them, with proper use, can save your life. Nearly a century ago, in 1914, 2 years after the tragic sinking of the Titanic, maritime nations from around the world realized a dire need to improve maritime safety and adopted the International Convention for the Safety of Life at Sea, or SOLAS for short. In the late 1950s, SOLAS came under the guidance of the International Maritime Organization, consisting of over 130 nations. Since then, the IMO has concentrated its efforts on maritime accident prevention. However, its primary goal was to establish a worldwide integrated system to respond to shipping emergencies. The most significant of these systems are the International Convention of Maritime Search and Rescue, or SAR, and the Global Maritime Distress and Safety System, abbreviated as GMDSS. GMDSS is a system whose basic concept is to alert authorities ashore and vessels in the vicinity of a distress so that they can assist in a coordinated search and rescue operation with minimum delay. GMDSS uses a number of frequencies and systems to accomplish this mission. Most importantly, GMDSS has introduced technology that has completely transformed maritime communications. Distress alerts may be sent and received over short or long distances using a combination of various radio systems, both terrestrial and satellite. Both the SAR and GMDSS work in conjunction to ensure that any distress call for an emergency at sea can be received and heard, and that the response to that call will be timely and effective. Thanks to the SAR and GMDSS, the days of a protracted rescue are mercilessly over. Today, with the success of modern technology with the GMDSS, maritime law has mandated that passenger ships and cargo vessels carry equipment designed to improve the chances of rescue following an accident. These include satellite emergency position indicating radio beacons, or EPIRBs, as well as search and rescue transponders, or SARTs. All of this advanced technology was initially born out of an invention made just over a century ago, the radio transmitter. There are two types of radio frequencies used to signal distress. A UHF, or ultra-high frequency, is used for long-distance communications, mostly as a means of communication between ship to shore, such as a vessel calling its home base. The VHF radio, or very high frequency, comprises the majority of radio equipment on the average vessel. All fixed VHF radios are equipped with channel 16, the emergency channel, at 156.8 megahertz, that is monitored by the Coast Guard and other international rescue services 24 hours a day. Portable VHF radios carried by crew persons and frequently found in life rafts and lifeboats have a few channels on them. In addition to channel 16, these portable units also use channels 6 and 13, which are monitored by other vessels and used for ship-to-ship communications. When using a radio transmitter to call in a distress signal, the proper procedure starts by first switching to channel 16, then by using the word Mayday.
Mayday, Mayday, Mayday.
This word is said 3 times, followed immediately by this information.
This is the motor vessel Sarah
1.
K.
Your vessel's name in radio call letters.
Motor vessel Sarah K.
2. The nature of your distress call.
We've hit an obstruction, taking water in the engine room, uncontrolled flooding. Our position is 29
3.
degrees, 30
Your location by either latitude and longitude, or GPS position, your current course and direction, and your bearings to nearby beacons or landmarks. 4.
How many personnel are on board your vessel, over?
This is
The number of persons aboard.
We have 6 souls on board at this time.
Vessel Mary Kay,
5.
Coast Guard Station
Your
on.
vessel's
Roger, sir.
description.
Can I have a description of your vessel, over?
Coast Guard Roger, we have smoke.
If time permits, you may also mention survival equipment
Roger,
and
we'll be
signaling
there within
devices
the
you
next
have
couple minutes.
available to
We have
you.
a visual of your orange smoke flare, over.
Although cell phones are becoming more integrated into our daily lives, they are not a guaranteed emergency device for use aboard a vessel or installation. There are many dead spots or areas where cell phones are rendered useless, especially out at sea. As such, it is better to use a VHF fixed or portable radio to transmit a distress signal. As with any safety device, training should be given to all crew members on the proper use of the radio equipment. Familiarity breeds safety. Also, be sure that frequent maintenance checks are done to ensure that the battery levels and equipment are in good working condition. A SART, or Search and Rescue Transponder, is a type of emergency transmitter that some vessels are required to carry that helps rescuers locate individuals or vessels in distress. In order for a SART to operate, it must be activated manually. SARTs are battery operated with an estimated battery life, depending upon manufacturer, of 96 hours in the standby mode and 8 hours when being interrogated by radar. A normal detection range for a SART mounted 2 meters above sea level by an average ship's radar is 7 to 10 miles. However, a search aircraft equipped with an X-band radar should be able to detect it from at least 30 miles when flying at an altitude of around 3,000 feet. When a vessel's X-band radar beam hits the SART, the device sends back a signal to the vessel's radar screen, which allows the vessel to locate it. This signal will either flash an indicating light, or in some cases, a second light or even a buzzer. This will serve to let the distressed persons know that an approaching radar is activating the SART. If the survivors have a portable VHF radio with them, they can use it to call the approaching vessel. It is legal to check the operation of a SART by briefly turning it on and exposing it to the transmissions of the ship's radar. If this is done on board, then the radar screen will be flooded with the concentric circles showing the proximity of the SART. Ideally, such tests should be conducted when there are no other vessels within radar range so as not to cause interference or false alarms. When activated, EPIRBs, or Emergency Position Indicating Radio Beacon, transmit a signal which is picked up by satellites and transmitted via land-based receivers to rescue services such as the Coast Guard. There are basically 2 types of EPIRBs with distinct, important differences. A 406 MHz EPIRB has several advantages over the 121.5 MHz EPIRB.
The most common and effective EPIRB is the 406 megahertz, and the way that works is whether it's manually activated or automatically activated, it'll send a signal to a satellite, and that in turn will send a signal to one of many Coast Guard command centers, and it'll actually give us a position or a latitude and longitude where that signal came from, so that the command center can dispatch the appropriate either vessel or aircraft to assist. Additionally, the 406 EPIRB has got a homing device which sends out a homing signal on a frequency of 121.5, to where if we're close to the vicinity of the distress, we can use a direction finder to actually home in on the vessel in distress.
406 MHz EPIRBs are available in 2 categories. Category 1 EPIRBs are automatically activated when submerged in water. Category 2 EPIRBs must be manually activated and released. An EPIRB should only be activated once you have abandoned your vessel or installation. Once you have activated the EPIRB, leave it on. Never turn it off, as it may confuse search and rescue units as to your position. A continuous transmission is vital for the satellites to confirm your position and for search and rescue units to pinpoint your location. EPIRBs are packaged in a waterproof single-unit container resistant to corrosion and other environmental effects that may occur in connection with use and long-period storage on ships or installations at sea. EPIRBs should be stored where they are easily accessible and won't be subject to physical damage. Proper registration of your 406 MHz satellite EPIRB is intended to save your life and is mandated by FCC regulations. Unlike a 121.5 MHz EPIRB, a 406 MHz EPIRB is programmed with your vessel's identification number. This information can be very helpful in confirming that a distress situation exists and in arranging appropriate rescue efforts. If the EPIRB is properly registered, search and rescue authorities all over the world will be able to use the registration information to immediately begin action on the case. If the EPIRB is unregistered, a distress alert may take as much as 2 hours longer to reach the Coast Guard over the international satellite system. Unregistered EPIRBs have needlessly cost the lives of several mariners since the satellite system became operational. To maintain the vessel's EPIRB properly, the Coast Guard recommends that a responsible crew member periodically examine them for water tightness, battery expiration date, and signal presence. First, always carefully read the owner's manual on the proper use of each EPIRB found on board the vessel. Depending upon manufacturer, 406 MHz EPIRBs may use a special type of lithium battery designed for long-term, low-power consumption. Batteries should only be replaced by a manufacturer-approved dealer or service center, typically every 5 years. Finally, it is important to conduct periodic operational tests on the EPIRB unit to make sure it is actually broadcasting. To test a self-activating EPIRB, slide the switch to the test position and hold it until the unit beeps and the strobe light flashes. For a manually activating unit, slide the switch to the ready position and reinsert the blocking key. If the EPIRB is accidentally activated, notify the watch officer so that the Coast Guard can be alerted. Keep in mind that activating an EPIRB is no guarantee that an immediate rescue will be forthcoming. Your survival and rescue depend upon staying alert to all potential means of communicating your position, which includes the use of pyrotechnics. Being in distress on the water, whether aboard your vessel, installation, or in the water itself, can be a frightening and dangerous experience. Not knowing if you're going to be rescued can be complicated by inclement weather conditions, such as turbulent seas, heavy swells, and fog, which only add degrees of difficulty in which a search and rescue unit can find you. It is for these reasons that an up-to-date supply of both long and short-range signaling devices should be aboard every vessel, installation, and survival craft. Obviously, the more varied signaling devices you have, the better chance you have of being spotted by rescuers. All marine pyrotechnic devices, including their ignition triggers and external surfaces, should be suitably waterproof, and the entire device should be kept in a tight, waterproof container that is easily accessible. Each signal must be clearly marked with the operating instructions in both official languages or a diagram clearly showing the manner of operating the signal. Additionally, each signal must have a date on which it was manufactured, the lot number, and an expiration date, which is usually 4 years. Expired pyrotechnics should be given to the proper authorities for disposal and never be thrown away at sea, since they could be washed ashore and cause injury to members of the public, particularly children who may tamper with them. If a device should fail to fire when operated, it should be immediately discarded. Since a lifeboat or life raft rides low in the water, it's important to have a flare or rocket capable of obtaining high altitudes. Once a rescue vessel or helicopter has homed in on your long-range signal and been sighted, using a shorter distance device, such as a hand flare or smoke signal, will further aid in your rescue by reducing the rescue area. Rocket parachute flares are good first detection devices for long-range signaling to rescue ships and helicopters. To fire a rocket parachute flare, remove the indentured top cap. Then remove the bottom cap and safety pin to release the trigger. Next, hold the rocket firmly in a ready-to-fire stance. Aim downwind. Fire vertically. Push the trigger lever upwards. Although there is little recoil with the firing of this type of flare, there is a sudden whoosh as the flare is fired, and so great care should be taken to hold the flare canister firmly. A typical rocket parachute flare can be seen for up to 40 miles and will burn up to 40 seconds. Under normal conditions, they should be fired vertically. If a strong wind is present, they should be angled away from the wind's direction. On days of low cloud cover, the rocket may be kept below the clouds by tilting the flare over to a 45-degree angle downwind before firing it. Shorter distance pyrotechnics are ideally suited when an approaching rescue vessel, airplane, or helicopter can be seen or heard nearby. The most common types of these short-range signals are handheld flares and smoke signals. There are two types of handheld flares that have differences in their activation. One type of handheld flare is operated by pulling the knurled handle to release the spigot from the safety gate. Then rotate the knurled handle clockwise until the two arrows are aligned. Ignite by striking the base of the handle a sharp blow with the palm of the hand. Hold up and point downwind. A second type of handheld flare is activated by removing the safety caps, then removing the paper cap from the firing end. Break the seal and remove it with a sharp pull to ignite the flare. These types of handheld flares will continue to operate during water immersion and can be seen for 5 to 10 miles. To avoid damage to your eyes, never look into the flare's bright flame. Most handheld flares are capable of signaling aircraft or vessels within 3 miles. They should be saved for close-range visual contact. These types of flares burn for a minimum of 1 minute and are accompanied by a trail of smoke. They should be used when visibility during the day is poor, in high wind conditions, and at night. They are especially useful in that they allow the rescuer to take a bearing on your position. Smoke signals can either be handheld or buoyant. A handheld smoke signal will produce a cloud of orange smoke and burn for about 40 seconds. A buoyant orange smoke signal is placed in the water after starting and floats upright, providing smoke for a minimum of 3 minutes and up to 15 minutes, depending on the type of device. A buoyant orange smoke signal is safe to operate on gasoline and oil-covered water. To operate, simply remove the plastic lid, pull the cord vertically, and throw the device overboard downwind. There's a 2-second delay after the cord is pulled, allowing you enough time to get the device into the water. For the comfort of you and the other personnel on your vessel, it's best to launch the smoke signals leeward and downwind. They should be used primarily during daytime hours and are most effective when rescue comes by air, as smoke is easier to spot against the sea than sky. In addition, they provide wind speed and direction for the pilot's approach. Both handheld and floating orange smoke signals also work best on clear days with light winds. On days with high winds, they lose their effectiveness since the smoke is rapidly dispersed. A day and night signal was originally developed to military specifications as a compact personal survival and life raft signal. It consists of a plastic outer case incorporating a red flare at one end for day and night signaling and an orange smoke at the other end for daylight use. Either end can be fired independently by means of a pull ring mechanism and the unused end stowed until needed. All of these types of pyrotechnic signaling devices can be used in conjunction with EPIRBs, SARTs, and your radio to aid in rescue from your vessel or installation. There are times when flares or smoke signals may not be available to you, especially if it involves an emergency evacuation of a vessel or installation. In cases like these, alternative methods of signaling may have to be used. These include the use of a whistle, a heliograph or mirror, sea dyes, a flashlight, strobe light, or luminescent stick, and finally, splashing wildly to indicate your location. Signaling mirrors may be found in the survival craft's emergency pack and can be used to reflect a light source, mainly the sun, in order to signal your location. A mirror has a small 1/4 inch hole in the center of it and should be reflective on both sides for maximum efficiency. To properly signal, hold the mirror 3 to 4 inches from your face and sight the ship or plane through the hole in the mirror. The sun will then be properly reflected on the target. Practice sweeping the horizon at all times, even if no rescuer is visible. Signals can be seen clearly at 10 miles and up to 40 miles on a clear day. If a signaling mirror is not available, any shiny surface, even a credit card or a piece of glass, may be used to reflect light back at a prospective rescuer. A whistle is simple to use. Simply put the whistle in your mouth and exhale deep breaths through it. When used in conjunction with another form of visual marking, such as splashing or waving of the arms, a whistle can be a very effective form of signaling, since a whistle's sounds carry further over water than the human voice and requires much less energy. At night, a whistle can be used effectively since visibility is limited by passing vessels. A whistle used along with a waterproof flashlight, strobe light, or luminescent stick attached to your life jacket can give your rescuer a better way to find you. There are other visual distress markers that can be used effectively during daylight hours. In calm conditions, sea dyes can be spotted by passing aircraft, as can flags. However, both can be inhibited by high winds or rough seas, which can make them difficult, if not impossible, to spot. Rather than using flares in a panicked fashion at the mere sight of a ship or aircraft, try to decipher its course and then wait until it appears to be at its closest point. At this point, use your most effective modes of signaling. Any distress device that is reusable, such as a mirror or radio, should be used first. Wearing a life jacket during times of distress is vital to your survival. All jackets worn by personnel should be reversible and able to keep the distressed person's head out of the water for what may be a lengthy period of time. Life jackets should be donned immediately at the first sign of trouble and before entering the water. Each life jacket should have securing straps and light reflective tapes. Some may even contain a whistle or small mirror for signaling. Other life jackets may also have a light that attaches to the jacket which, depending upon manufacturer, can be used up to 8 hours and be seen up to 1 mile at night. An immersion or survival suit is another vital piece of life-saving gear. The immersion suit may protect a person in cold water from the deadly effects of hypothermia. In 50-degree water, it can take as little as 30 to 60 minutes before unconsciousness takes over. For a person without thermal protection in colder water, you may only last 15 minutes. Once you have been spotted by the rescue aircraft or vessel, it's important to remember to stay calm and be focused on the task at hand. There are many ways you can be rescued, either by a helicopter lowering a basket for you, by a fast rescue craft or vessel assisting in your recovery, or by you aiding yourself by climbing up a ladder or scramble net attached to the side of a vessel. One popular rescue device that has potential for quickly retrieving a man overboard is a high-powered long-distance line-throwing device, which can be fired from a vessel or installation to a distressed person or disabled vessel in the water. A buoyant head attached to the rocket device allows for personnel in the water to grab hold of it. Once the line is secured, you can be pulled toward the rescue craft or vessel. This particular speedline line-throwing device is operated by first removing the front cover and inserting the rocket propulsion unit inside the launch tube. Wrap the excess cord from the rocket unit as shown. Tie down the trail line to an anchored position, either on shore or on board a vessel. Point the arrow on the unit in the direction of the vessel, installation, or personnel in the water. Never point the speedline device directly at an individual, vessel, or aircraft. Remove the safety pin and hold in firing position. Aim over the target and fire. If a misfire occurs, hold the unit in firing position for 1 minute, then dispose of overboard. Regardless of the method of rescue involved, it's important for distressed crew personnel to remember to never let down your resolve and to always listen to what the rescue crew is telling you until you are safely aboard the rescue craft or vessel. Although the majority of your time aboard your vessel or installation is spent earning a living, taking the time to learn the use of marine distress signals will ensure that you and your coworkers, associates, or even passengers will have an excellent chance of surviving the potential hazards of the sea.